metals, so I love giving up electrons. What about you guys?
Shut up, nerd.
I'm a neon atom named Spencer, and I'm a noble gas, so I don't really need to interact with y'all.
I'm a chlorine atom. All I really care about is taking other people's electrons.
Okay.
I wish I was a noble gas.
You too.
Today in class, we will be learning how ionic bonds form, how to apply the octet rule with ionic bonds, and why cations form with specific anions.
Ionic bonds are important because they are crucial to chemical reactions. In order for a chemical reaction to occur, we needed elements to form with other elements, or elements can separate from a combined molecule. Can one of you please come up to the front of the class to share what you researched about what ions are and how ionic bonds form?
I got this. Ions are charged molecules of atoms. Ionic bonds form when one atom of one element completely takes away one or more electrons from a different element. Elements on the left side of the periodic table usually give away their electrons, while elements on the right side of the periodic table tend to accept electrons, unless you're noble like I am, of course. One example of this can be shown with sodium and chlorine. Sodium has one electron in its outer shell, while chlorine has 7 electrons in its outer shell. Chlorine wants to get 8 electrons in its outer shell, so sodium will give up 1 electron, and they will both become stable. Ionic bonds can be seen between just 2 atoms, but we can observe them in large compounds like sodium chloride. Here is a reaction of yellow chlorine gas with the solid sodium to form the crystal of sodium chloride. This reaction involves the formation of ionic bonds where chlorine removes the valence electron from sodium. Water is used to start the reaction. You can see where the salt has formed in the place where the chunk of sodium used to be.
Good job. I'm going to build off of that and explain the octet rule. This rule states that main group elements tend to undergo reactions that leave them with 8 outer shell electrons. That is, main group elements react so that they attain a noble gas electron configuration. The noble gas electron configuration is a filled S and P subshells as well as their valence electron shell. Why are they trying to attain this certain configuration? Well, the noble gases are the most stable, so therefore they are the most favorable configuration. Furthermore, the noble gases are the least reactive elements. In ionic bonding, certain elements bond with other specific elements to follow the octet rule. The pattern is as follows. Mallory, could you tell us this pattern?
Oh my gosh, yes. Please pick me. Oh my, yes, for sure. So, the elements that tend to give away their electrons are going to take on the electron configuration of the previous period's noble gas. For example, if potassium forms a cation, it's going to turn into the electron configuration of argon, because that's the noble gas of the previous period. In general, group 1 atoms are going to react with group 7. The alkali metals, like me, are going to go with the halogens. Group 2, which are the alkaline earth metals, are going to go with group 6, and so on. So they'll move in within. The transition metals kind of vary a little bit. They can have +1, +2, or +3 charge, but they are cations.
Hannah, can you come up and show the class how you write ions in chemical reactions?
Do I have to? In ionic reactions, cations like sodium form when they lose an electron, giving the atom an overall positive charge. So we write a plus sign by the symbol. Likewise, anions like chlorine form when they receive an electron, giving the atom an overall negative charge. so we write a negative sign. When atoms lose more than one electron, we write the number next to the sign. Like when magnesium loses more than one electron, we write 2+. And that's it.
Alright class, I hope you learned that ionic bonds are formed when atoms gain or lose electrons and form a molecule together. The Octet Rule states that elements will form these bonds in order to achieve a noble gas configuration. Cations on the left side of the periodic table lose their valence electrons, while anions on the right side of the periodic table gain electrons to form the noble gas electron configuration. Alright guys, class is dismissed.
Wow, Spencer, your presentation was so good. How are you so good at chemistry?
Well, you know, the only reason I'm so good is because I'm a noble gas. If I was unstable like you two, I wouldn't be that great.
Yo, sodium, give me your electron.
Oh my gosh, that would be perfect because I have one valence electron to give and you have one to take, so we'll both have full valence rings. You can totally have my electron. Oh my gosh, now we both have valence shells filled.
Now we're just as cool as him.
Soldier boy, tell me. Hey, I got this new damn for y'all called the Soldier Boy.